a simple carbon-sulfur nitrate solid rocket propellant, which oxidizer, potassium nitrate or sodium nitrate, will produce the most thrust? We predict that the propellant with the highest enthalpy of formation will produce the largest amount of thrust. In this case, we think it'll be potassium nitrate, with the standard enthalpy of formation being negative 495 kilojoules per mole, whereas sodium nitrate's enthalpy of formation is negative 467 kilojoules per mole. A rocket is able to fly because of the hot expanding gases that are ejected from the nozzle when the propellant mixture burns. The nitrate's purpose is to provide the oxygen for the carbon in the fuel to combust. This is necessary because the air does not have enough oxygen to sustain a vigorous combustion of the carbon, in our case, carbon black. In our rocket, powdered nitrates were used to provide the oxygen needed for the reaction of carbon and sulfur. To measure the thrust of the motor, we constructed a homemade chart recorder using the instructions found in Amateur Rocket Motor Construction, a complete guide to the construction of homemade solid-fuel rocket motors by David Sleater. In our experiment, we used a commercial B64 rocket engine as our control. We then had two homemade rocket engines made with either potassium nitrate or sodium nitrate. The chart recorder was calibrated before each test of a motor. Modeling clay was placed in the PVC cap in order to hold the rocket engine in place as it was burning. In our test of the rocket motors, we observed the failure to produce sufficiently recordable data in our homemade rockets. We did, however, notice that the potassium nitrate engines produced slightly more thrust, though it was not recorded due to the sensitivity of a recording device. We can come to this conclusion because of the audible increase of escaping gases and to the visually noticeable higher velocity smoke and molten nitrate coming from the nozzle.